Welcome to The Explainer. Today, we're tackling something huge, a totally new field that's basically trying to figure out how to build on top of all the AI hype. We're talking about AI engineering. This quote from AI expert Chip Huyen, it just hits the nail on the head, right? When ChatGPT dropped, it felt like this collective disorientation. We all saw this incredible, almost magical new tech, and everybody was left asking the same thing. Okay, so what do we do with this? Exactly. How do you actually go from a demo that blows your mind to a real product that people can use every day? Something reliable, something useful. Well, that's where AI engineering comes in. It's the new discipline that's all about building real-world stuff on top of these crazy powerful models. All right, so let's dig in. What is AI engineering, really? And why is it such a different beast compared to what we were doing before? The best way to think about it is like this. It's the whole shebang. It's the end-to-end process for actually making something useful. We're not just talking about playing around with a model. We're talking about the entire journey, from picking the right AI to actually getting a product out there and keeping it running. And this right here, this shows you just how massive the shift has been. See, with traditional machine learning, engineers would spend so much time on something called feature engineering, basically just getting the data ready for a model they were building from the ground up. But now, the whole game has flipped. AI engineering starts with a huge, powerful model that already exists. The job isn't building from scratch anymore. It's about expertly guiding that model using things like prompts and fine-tuning. Okay, so if AI engineers are the new builders, what are they building with? What are the new bricks and mortar? Well, they're called foundation models. And this is the crucial part. A foundation model isn't some single-purpose tool. Nope, it's been trained on a mind-boggling amount of data, so it's a generalist. It's like a Swiss Army knife. You can adapt it to do almost anything, which is why it's the starting block for pretty much every modern AI application you see today. And you can really see the journey they've been on. It started pretty simply, with basic language models. Then came a breakthrough that let us train them on, well, basically the entire internet. That gave us the large language models, or LLMs, that we all know. But now we're at the next frontier. We're adding images, video, audio, turning these things into true foundation models that can see and hear and understand the world a little more like we do. Right, so you've got this incredibly powerful, super general model. But how do you tame that beast? How do you get it to do one specific thing and do it really, really well? Well, before you do anything else, you have to figure out how to measure it. Think about it. How can you improve something if you don't even know if it's working? That's why evaluation is the absolute bedrock of AI engineering. You've got to build a solid, reliable way to test if the model is actually doing the job you want it to. If you don't, you're basically flying blind. You're just guessing. So, once you've got your testing system in place, engineers basically have two main tools in their toolkit. First up is something called RAG. That's Retrieval Augmented Generation. The easiest way to think of RAG is like giving the model an open book exam. You're feeding it the right documents at the right time so it can give you answers based on actual facts. Then, the second tool is fine-tuning. This is more like giving the model some special coaching. You train it on a smaller, really specific set of examples to teach it a certain style or skill. And this little phrase, honestly, it's the perfect way to remember the difference. If you remember one thing from this explainer, make it this. Fine-tuning is for form, and RAG is for facts. It's that simple. You use RAG to give it knowledge, and you use fine-tuning to give it manners and style. It's just a brilliant rule of thumb for any builder. But here's the thing that makes building in this space so wild. It's not just the tools themselves, it's that the ground is literally shifting under your feet as you build. The entire field is moving at an absolutely breakneck speed. Just look at this to get a sense of the pace. This chart tracks how fast open source projects get popular online. And what you're seeing is that AI engineering tools are gaining traction way faster than even huge technologies like Bitcoin or the web framework React did in their early days. It's unreal. We're talking new tools, new techniques, new models, popping up almost every single day. And on top of that speed, you have the most infamous problem of them all, hallucination. This is that bizarre thing where the AI just confidently makes stuff up. It's kind of like this weird digital delusion where the model literally doesn't know the difference between a real fact it was trained on and something it just invented on the spot. It's a huge, constant risk that engineers are always fighting. And all of this, the good and the bad, it really boils down to one fundamental truth. A normal computer program, like a calculator, is deterministic. 2 plus 2 will always equal 4, period. But an AI model? It's probabilistic. All it's ever doing is predicting the next most likely thing to say. That's where its incredible creativity comes from, but it's also the source of all the weirdness and inconsistency. So at the end of the day, managing that probability, that is the core challenge of AI engineering. So next time you chat with an AI or use one of these tools, just take a second to think about all the engineering happening just under the hood. It's this brand new field of builders, all trying to figure out how to create something solid and reliable on top of what feels like constantly shifting sand. And it leaves them and us with the biggest question of all. It's not just can we build it, but how do we build it responsibly?